So be prepared for that. What? There's an error with my USB. It's right here. That's good. I'll type in Zoom. That way we can save it to that, hopefully. We'll find out. If not, I'll make one at home. Should be. Okay, you guys ready for this? So I am recording now. So this is just for study purposes. I am not doing your homework for you. Just getting out of the way in case I have someone get in trouble. This is just for purposes. So can someone tell me what chapter 15 is about? That's the first set of questions. What was chapter 15? Equilibrium. What is equilibrium? Kind of. That's Le Chatelier's principle. It's balance, right? Equilibrium just means equal, right? And then beryllium, another way of saying balance. So equal balance. And then, oh no. Andreas wants in. Hi, Andreas. Gotta clear this. I'm used to doing Zoom things, not this. Okay. So, equilibrium is going to be where you see these two little arrows. That's equilibrium. So if you don't know what that means, is in Chem 113, we lied to you. We lied to you to make it simpler, though. We told you chemicals only go in one direction. That is not always true. In most cases, they go in both directions. This is the forward direction. This is the reverse direction. Correct? This is also referred to as the right side and the left side. So the two R's do not go together. Do not mix the two R's up. So when something is at equilibrium, what does that mean?
The rates equal the products.
Someone said it right.
The rates equal the products.
Could be equal to 1. True. Well, that's one way. That one's kind of appeasing. I see something like that, right? What's a limiting reagent? Does that have anything to do with equilibrium? No. Right? The rates of the forward and reverse reactions are equal. Right? Okay. That's true. I like that one. That one looks pretty good. This one right here, though, let's put this one. All chemical reactions have ceased. Is that true?
No.
That's definitely not true. So now between A, C, and D. Yep, 1 second. Some people having trouble. So I'm going to email this to someone real quick. Of course, I closed out of my email. But the answer basically for number 1 is going to be, why can't I go email? Go to the email. Quick links, email. Okay, I hit the button a third time. Download it. Marissa, I'm just going to forward someone your email real quick just so they get access to it real quick. Is that okay? Okay. Now your address. Should be able to get it now? Cool.
Yeah. Thank you.
So, at equilibrium, the rates of the forward and reverse reactions should be equal to each other. Right? Makes sense. Which one's that? C. Good. What's wrong with A? Rate constants. Those are not the same thing. So let's hypothetically talk about this real quick. This is going to come up. Might as well tell you guys this now. If the rate constant for this side, the forward reaction, right, is something, the rate constant for the reverse reaction will not be the same thing. Most likely will be the inverse of that thing. Does that make sense? Because it's the exact opposite. Okay, that's why A is wrong. The answer should be C. Okay, moving on. Number 2. Which of the following values will change an equilibrium constant? Now we're talking about the constants. So what is an equilibrium constant? What's the letter we associate that with? K. Anytime you see the word K in chemistry now, that's a constant. I know it starts with a K and not a C. I get that. That has always pissed me off. I'm dyslexic and it still bugs me to this day. But K is a constant. So let's look at this. So the constant of something is equal to the products over the reactants. Correct? So that's true. However, the K value will always be true if I somehow increase the amount of products I have, right? I theoretically will increase my K value. That's true. If I increase the amount of reactants I have, I theoretically will decrease my K value. But no matter what, if I leave the reaction alone for long enough, it will go back to equilibrium. The K value will be there forever. There's only one thing that can change K, and that is temperature. So every time you see equilibrium, you'll see at a certain temperature. That just means that's the temperature for that K value. Does that make sense? So the only thing that can change K is a change in temperature. Everything else will affect it, but it will never change K. Okay, so the answer for number 2 is C. Because only temperature can affect a constant. And if that doesn't make sense to you, what is 0K? 0 Kelvin, what is that? Absolute zero. That is colder than the heat. It's basically what happens when the entire universe just ceases to exist. When all life ends, that's absolute zero. Matter does not move at that point. So that affects a K value, right? So if that can affect K, it's the only thing that can affect K. Okay. Okay. No. No, he would not. There's no reason, because if I give you one, so for example, if the K value for a question is 2 at 273 K, right? If I give you a different temperature, you cannot use that value, right? You might ask me to figure out how to solve it because it's a little bit different, but you won't give you 3 different temperature values. That's a bit too much. Okay, so equilibrium. What is equilibrium? Okay, already, okay. Okay, that's fine, John. That's why I gave the Zoom link. So, I'm gonna ask you guys a question. Let's see if you guys can answer this question. How do you guys make a hamburger? Okay, put what on the burner? Okay, how do you make a hamburger? What is it? How do you make a hamburger? You actually are correct. You actually answered my question correctly. It kind of makes me mad. Yes, so most people say just put a meat between 2 buns. You can't do that because I could just go eat raw meat and you told me how to do it. Chemical reactions, again, are more complicated than you guys have told me before. There's always a desired response or desired chemical reaction, which is this guy. Now, we can manipulate other chemical reactions, such as this, to get to that. So, let's look at these 2 chemical reactions. We'll call this guy 1, we'll call this guy 2. Okay, so, what's the difference between those guys? They're flipped, right? See how our hydrogen and iodine are reactants on this side? But over here, they're products. Okay, there's only half of them. That's good. Only half, right? So we divide these guys by 1/2. Okay, we're gonna do that, correct? So we divide those guys by 1/2, and we also flip it. We'll get the bottom one. Does that make sense? You guys see that? That is a difference, but that's just a mess up on their part. It is an equilibrium, yes. Okay, so tell you guys this, that K is equal to products over reactants, right? That is true for this guy. However, this guy right here, number 2, is the exact opposite. So what happened was their product and reactants flipped. So this guy's K value is actually reactants over products theoretically. Does that make sense? What is this? These two have a relation to each other. What are they? They're inverse of each other, right? What that means is you can take this Kc value or K value and just take the inverse of it. That's cool. That's one way of doing it. That's what we're going to do. So the equilibrium constant for the first one, number 1, is right here, 794. So we'll do 1 over 794. Are we done yet? No, we just flipped them theoretically. You also told me, guys, that this one's about half, right? Now, when you change something with the K value, right, if I put a 1/2 right there, right, that value theoretically goes as an exponent on these guys, correct? So what is an exponent to 1/2? What's that the same as? It's the exact opposite of squared. Square root. So if I take the square root of the inverse of 794, I'll get the answer. Does that make sense? That's how you approach this problem. Yeah, they will do that from now on. If you don't do all the steps, you'll show the answers for every single step. Unfortunately, that's just how it is. It sucks, I agree. It's just how it is. So what do you guys get when you guys plug that in? Hey, you guys got that? Yes, so I took half of the first one right there, right? And so I took half of the first one. That's theoretically going to be an exponent. An exponent of 1/2 is just a square root of it, theoretically speaking. Does that make sense? Okay. Zoomies, any questions? If you have questions, type in the comments so I can see it. Because I can't see your faces because you probably don't want your face to be recorded. Cool. Okay, let's hide in number 3. And one's like it. Let's talk about this guy right now. So, let's start with this. Kc, K is a constant. What's that C mean? Concentration. K is a constant. What's that P mean? Constant pressure, right? See a K with an F. That's the constant. That's the rate constant for the forward reaction. Kr is the constant of the reverse reaction. You notice they're all big K. They're all just K values. We just put a subscript telling you what they mean, right? They're still going to be products over reactants. That makes sense. Okay. In this case, we are dealing with a Kp value. So Kp is equal to products over reactants. Good. Now, when I'm dealing with this stuff, when I'm dealing with K values, right, mainly Kp, there are 2 types of matter we do not like. What are those 2 types? No, we like gases. What do we not like?
Solids and liquids.
Nope, it's solids and liquids. We do not like solids, and we do not like liquids. The reason because of that, because they're pure. They don't do anything. They're useless to us as chemists. We like when things do something, right? You guys like it in lab when something actually happens. If nothing happened in lab, it would be very boring. So I'm crossing that guy out because it's a solid. I'm crossing this guy out because it's a solid. We don't want solids. They don't do anything in chemistry. They're just a hunk of rock. They don't really react. So remember, Kp value, products of reactants. So what are my products? H2O, good. Is that done yet though? No, That 2 right there is an exponent, so it's squared. Good, what else do we have? CO2. Good. What are my reactants? CH4. Good. So let's look at this. All your answers in here have this p-value. Again, what does p mean? Pressure. Do not get scared by that p-value. That p-value just means pressure. We can ignore that right now. Now let's talk about a difference, because some of this stuff still confuses you guys. What do brackets mean? What do parentheses mean? Anything not concentration. So I see concentration right there. No, no. I see concentration right there. That's no, no, right? We want one that looks just like this. And the one that looks just like that is A. Correct? No, because am I, what am I looking for right now? Sorry about that. Sound like Porky Pig. Look for pressure. There is no brackets when I'm dealing with pressure. Does that make sense? Okay. Moving on, moving on. The next one is a fun one. Okay, if any of the Zoomies have questions, let me know. This is being recorded though, so if you want to talk, you can talk, or you can type in chat. And feel free to ask questions, guys. I'm here to help you. So let's write this guy out. 2NO, N2 plus O2. You notice I didn't write any units, right? Because what I did is I looked. They're all acceptable, right? They're all acceptable. You don't have to care anymore. Cool. That's why I did that through there. A closed vessel is injected with 36.1 atm, which means pressure, of NO. At equilibrium, what is the partial pressure of O2? Huh. So we're at equilibrium, right? Because we're given an equilibrium constant. And then I inject something inside of that. That sounds like I'm changing something, right? Well, guess what? If you're changing something, we have this new fancy-dancy thing called an ice table. So if you guys don't know what ice table is, because the instructor hasn't told you yet, I means initial. So what was it initially at? Right? We shouldn't theoretically have any products yet. Usually don't have products when we do an ice table, because that reaction isn't gone yet. Right? How much did I inject in? I injected 36. So I'll have 36.1 atm of stuff. Good. The change. So what's changing? How much of this stuff is used up? Do you guys know? No, you don't know. So it's a variable, right? That's an x value. Now, reactants, positive or negative? Reactants. They're negative. They are used up. They go down. Products are positive. They go up. Does that make sense? Good. One more thing, though. There's 2. For every 2 moles, I make one of these guys. We have to denote that. So it's minus 2x. It's going to be used up twice as fast. So the n value, which is E, will be 3x.1 minus 2x. We'll have plus 1x here, plus 1x here. And these are my new variables that I will plug in to my constant. So Kp is equal to N2, parentheses of O2 over the parentheses of NO squared. I'm just going to take all this stuff right here, and I'm just going to rewrite it up here with the actual numbers, okay? And I'm jumping around a lot. They don't give me a lot of room to write on. So we actually are giving the Kp value, right? So I'll write the Kp value right here, and that is 2.4 times 10 to the third. That is equal to hey, x value. What's x times x? X squared. Good. And then we have 36.1 minus 2x squared. Oh no, this is looking like a quadratic formula problem, right? That's what I thought so too. So you realize something. This is being squared, and that's being squared, right? So if I took the square root of this entire side and the square root of this entire side, I just gave myself a ton of work. Does that make sense? Because if I took the square root of this side, that cancels all those stuff out, right? There you go. So the square root of 2.4 times 10 to the third is, let me check my notes real quick, that's why I did this problem before, going to be equal to 49 equal to x over 3x.1 minus 2x. To get x by itself, we're going to multiply by this side. Get over here, right? 36.1 times 49 is 768. 49 times 2 is 98. That is all equal to x. Oh, it's an x right here, sorry. 98x. Get the x's on the same side, so minus an x on this side. Or, yeah, minus an x on this side if you want to. Or add 98x, whatever floats your boat, right? Minus x, 99x, subtract 1768. Basically, you have 99x is equal to negative 768. Will you have a problem like this in your test? Probably. Won't be this hard, though. Same concept, though, that's tested. Once you solve all that, x value will be b. The entire reason this question is being asked is it wants you to know that your Kp value is equal to your reactants, your products over reactants, If you have to find one of your products, right, you plug that in and solve for it. That's all it's trying to try for. This was in your homework a lot. This one is just way more complicated than that. This one took me about 10 minutes to figure it out because I thought it was a quadratic formula. I'm glad I don't have to, because you guys don't want me to see the do the quadratic formula. It's been like 7, almost 10 years since I've done the quadratic formula from high school. Okay. Number 6. Oh gosh. We talked about K before, right? Kp, Kc, Kf, Kr. What the hell is this Q right here? So what is Q? Do you guys know? You guys talk about Q yet in class? Some of you guys, it's gonna be blank, scary looks. That's fine.
Yeah, we talked about that.
I told you that the K value is always going to be what that's equilibrium, right? It's always going to be equilibrium. So if A plus B gives you C plus D, and the equilibrium for that guy, let's say, is just 4, right? Kc of 4, whatever, right? That's always going to be true, no matter what, at a certain temperature. However, let's say for some reason we're in class and I decide to give you guys like 4 moles of this, 7 moles of B, 9 moles of D, and 8 moles of C. I just plug those numbers in for no reason, right? And I solve for Kc value again, right? If doing that, that's theoretically called a Q value instead. It's called the quotient value. The Q value is just the K value experimentally. Does that make sense? This is what you experimentally are finding out. So let's say my Q value is 7. What's bigger, Kc of 4 or Q of 7? Q of 7. So if Q is bigger, right, I theoretically have made more products than I theoretically should have at that equilibrium constant, right? Because K is my equilibrium constant. It's what it needs to be. I've made more products. I am not at equilibrium, right? I've made too much stuff. How do I fix that? Add more stuff to the other side. So you break more stuff down. You shift it towards the left. You shift it towards the reactant. You shift it in the reverse direction. All of the things I just said mean the exact same thing. Which is why I don't like chapter 15, because there's 7 ways of saying the same thing. It's very annoying. You will see that. But you're going to shift it towards the reactant side or the left side. If K is bigger, right? What does that mean? You make more products. Because this guy isn't done yet, correct? He needs to become K. Correct? You're going to make more products. You said reactants. You're going to make more products. So if this is true, right, they're equal to each other, right? Oh, let's just do a different color. So if your K value is bigger than your Q value, right? You haven't, Q isn't done yet theoretically, right? It needs to become equal to K, right? So it needs to get bigger. And how does Q get bigger? You make more stuff, right? Because remember, Q and K are the same thing as equal to products over reactants, right? That's what Q is equal to. That's what K is equal to. How does Q get bigger? You make more stuff. Does that make sense? Okay, so if your K value is bigger than Q, you make more products. If your Q value is bigger than K, you make more reactants. Does that make sense? I may be saying that wrong, but yep, because they're not at equilibrium. Equilibriums are equal to each other. Boom, boom, good job. At equilibrium, the reactant quotient is undefined. If I have a Q value, I most likely will have a K value, or vice versa. I tell you it's at equilibrium, right? So it can't be undefined. If the equilibrium quotient is undefined, the K value is undefined. That's a stupid question. So it can't be right. Good. The reaction quotient must be satisfied for the equilibrium to be achieved. I don't know what that means to be satisfied. So no, the only left over is E. They equal each other. Does that make sense? You can't satisfy a constant. It's always there. Okay. Zoomies, if you have questions, just send something in chat. No one's said anything in chat yet. Okay. You are being recorded though. You're not up on the screen, but yeah. Okay. Ooh, in the cold gasification process, carbon monoxide is converted to carbon dioxide via the following reaction. Okay. So, KC. What's the C stand for? Concentration. What's another way of saying concentration? What? Well, that's what it equals. That's what Q equals. What does the C equal? Concentration. What's another way of saying concentration? What? Molarity. What's molarity? Moles over liters, right? C is equal to big M, molarity, which is the same thing as equal to moles over liters. In the experiment, 0.35 moles of carbon monoxide and 0.4 moles of H2O are placed in a thing. At equilibrium, something happens, right? Well, I got a problem. Those are moles, right? I got to convert it to big M. Now, luckily, they're nice in this problem. What's your volume? 1, right? So what's 0.35 divided by 1? 0.35. Nothing changes, right? So we can keep the same numbers. I want you guys to point that out, though. And for future problems, it will not be like that. There is something I did notice, though, that is very concerning. At equilibrium, there is stuff remaining. If it ever mentions stuff is remaining, guess what you have to do? Ice table. So CO plus H2O gives you CO2 plus H2. Ice table, initial, change, end is what that refers to. Cool. So initially I have 0.35 of this and 0.4 of this. How much stuff do I have at the very beginning of the experiment initially? I don't have any products yet, right? Good. So first off, is there any numbers in front of my things I have to worry about? No. Good. This is going to lose by something. This is going to lose by something. This is going to gain by something. This is going to gain by something. Does that make sense? Right? Because I can only make only products I make is how much stuff I use up or lose. Correct? Well, that's at the very end. I'm trying to show you guys how to do it step by step. So at the very end, I have green 0.19 remaining. Well, that from that information right here, from this column, you can figure out what your X value is, right? Cool, what's your X value? It's going to be the difference between 0.35 and 0.35. 0.16? You were correct, it is 0.16. Okay, so now we know that X is equal to 0.116. So I'm going to erase my X values and just plug those numbers in. Well, that was not supposed to happen. Well, that was a really big eraser for some reason. Cool. Okay. So 0 plus 0.16 is what? 0.16, right? Nothing changes. Right here, I had 0.4. 0.4 minus 16 is what? Yep. 0.24. 0.19. Okay. With the stuff given, I can figure out my Kc value. Jocelyn, I beat this into you already. What is Kc equal to? Products of reactants. Plug in your products, plug in reactants. What this will look like is Kc is equal to 0.16 squared over 0.19 times 0.24. Plugging those guys in should get you the answer, which is E, for my calculations at least. Okay, does that make sense? Zoomies, how are we handling it? E.
Thanks.
E, 0.56.
How do you try and keep all this order?
Okay, whoop, gonna erase this entire thing. Cool. Going down here. Ooh, that's a German word. Something bromide decomposes according to the following equation. A sample of this was placed in the container containing know that at equilibrium, the flask contained that. How many moles of this, respectively, are in the flask at equilibrium? Okay, we have stuff remaining, right? What's that tell you we have to do? Ice table. Hopefully you guys start liking ice tables, because guess what all chapter 16 is about? Ice tables. Guess what the rest of Chem 115 is basically about? Ice tables. Why? Because we got to ask you guys some tricky questions later on. No. Ice tables is a new concept when I was a thing. There used to be other ways of doing it. Ice tables is the easiest way of explaining it. Okay. So initially, I have, let's do, yeah, got 0 of this, 0 of this. And I have 0.64 of this. Change, I lost some stuff, right? What's my change going to be? Positive or negative for reactants? Negative. Is there a number right here? A 2. Good. Do I know how much I have theoretically yet? It's an X value then. Good. For products, positive or negative? Products are positive. Good. Do we have numbers right here? Yes or no? 2 plus 2x plus x. That 2 is very important, right? Because you're going to be making twice the amount of the other one you're making. Good. So, and then I have down here, how much is left? 0.46 remaining. So what is the x value? 0.09. Do you plug in the x, the 2x as well? Why did I not show my work for this one? Yeah, that's correct. So, you guys need to figure out how to do this. 0.64 minus 2x is equal to 0.46. Hey, zoomies, real quick, you can see my screen, right? You can see the numbers I'm writing?
Yep.
Yeah.
Yep, okay. I'll make sure you see the numbers I'm writing, because that'd be really bad if you weren't. It's 8 questions we went over with nothing. Okay. Subtract this side, and divide by -2. X is equal to 0.009. Does that make sense? You guys got that? Or no? Okay. Plug those in for the x values. So, what's 0 plus 0.009? Not 009, 09, my bad. 09. 09. So 0 plus 0.09. What's 0 plus? What's 0 plus 0, 0? Yeah, blah, blah. What's this? What's this going to be right here? 0.09. Good. Plug that in. Plug the x value in for 2x. What do you get? There you go. You figured out your concentrations at the equilibrium. Now, which answer has those values in there? B. Does that make sense? Okay. So looking at this column right here, the blue column, right? I have my initial, I have my change, I have my end, right? Solve for x. We do it up here, right here, right? So 0.064 minus that, and you just take that, divide by 2x, you'll get that value. Does that make sense or no? Nope. Okay. You understand what you did wrong though? Yep. That's that.
How do you know to like?
Got it? Okay. Here is the biggest concept. Oh, I don't want to do that.
I had a question.
The biggest concept of chapter 15 is called Le Chatelier's principle. Le Chatelier was a French scientist. You guys know, if you guys study history, the French are assholes, especially in chemistry, because they invented all the weird principles in chemistry. The Chatier's principle basically is whatever you do to one side, you have to do the exact other side because it has to be at equilibrium. So, okay, what's your question?
Can you hear me?
You can speak if you wish. It's easier.
I am.
I cannot hear you. Wait, turn you on real quick. Say something.
Hello?
Ah, there you go.
Okay.
Hi.
Okay, so how do you know to divide it by the 2x? Did we do that for the question 7?
I did not. The reason we divide by the 2x is because numbers pop up here.
Oh,
We actually have 2 there, right? Those
Okay.
2 there mean something. It means they're used up twice as much, right? On the reactant side, they're
Okay.
used up twice as fast. On the product side, you make twice as much as them.
okay. Okay, thank you.
Of course, always ask questions. And then when you talk about Kc values, those 2 become exponents. Okay.
Okay, thank you.
Yeah, of course. All good. You have more questions, this guys speak. It's all good. Okay, Le Chatier's principle. Frenchman was an asshole. He also did some weird other things that were questionable during his time, but that's for another time. Okay. At a constant temperature, what's that mean? Are we changing temperature at all? No. The concentration reactants product. So, which of the following reactions would increase an increase of pressure? Ah, we're already starting off hard. So, imagine I have a beaker or a pot, and it is closed. And inside that pot, I have some products. And I have some, nope, I have some reactants, right? If I decrease the volume of that, right, it's going to affect the ones that have the highest concentration. If I increase it, it's the exact opposite. So Le Chatier's principle states that an increase in volume will increase the side with the most. A decrease in volume increases the side with the least moles of something. Now in Chem-115, you should have realized that volume and pressure are inversely proportional to each other, right? If the volume is decreased, the pressure goes up. So just do the exact opposite. A decrease in pressure means this. An increase in pressure means that. Does that make sense? Yes or no? You're giving me a weird look. You good? See, I want to talk about that right now. It's the amount of moles of gas. So, here, how many moles of gas does the reactant side have? 4. How many sides does the product have? 2, right? Does that make sense? That's what I mean by the most and least. The most amount of moles, the least amount of moles on which side. Always compare products reactants. So an increase in pressure, we're going to favor the side with the least, right? But what I'm looking for will not have a change. So if I'm not going to have a change, what's that mean? It's not going to change at all, right? If I increase pressure, it shouldn't change. Okay. Reactants, he told me has 4. Products told me has 2. If I increase pressure, is it going to shift the reaction one way or the other? Yeah, it's going to shift it towards the right. We're going to make more stuff, right? Because go to the side with the least amount of stuff, right? Same thing here. They're not equal to each other. They're not equal to each other. They're not equal to each other. Hey, they're equal to each other in E. Does that make sense? So increase in pressure should not do anything because the amount of moles on both sides are equal to each other. Make sense? Yes, it would. But with Chatier's principle, we only care about temperature if you're given a delta H value, or told if it's exothermic or endothermic. Okay. So the answer for number 9 is E. Hey, number 10, Le Chatelier's principle. Number 11, Le Chatelier's principle. Hey, multiple questions in a row, Le Chatelier's principle. What do you think chapter 15 is mainly about? Le Chatelier's principle. Le Chatelier's principle is that adding O2. So, where's O2 found on this guy right here? The product side. Good. So if I increase my product side, how does the equilibrium react? Do I make more products or make more reactants to counteract that change? I'm going to shift towards the left to make more CO2. Does that make sense? Number A, decrease the partial pressure or the amount of CO2. That's the exact opposite of what I just said. Decrease the value of equilibrium constant. Huh. Equilibrium constant is equal to what? What is K equal to? Products over reactants, right? If reactants go up, what happens to my K value? Goes down. So if I force it to go, if I make more reactants, what happens to my K value theoretically? Goes down. B looks appetizing right now, but let's just check to make sure. An increase of partial pressure at equilibrium. Huh. Interesting, right? Increased partial pressure of CO2. I like that one. That one also is interesting. An increased value of the equilibrium constant. Nah. Increased value of carbon monoxide. Well, no, we're going to make more reactants, not products. So, here's the problem with this question. It says at equilibrium. What does equilibrium mean? They both equal each other, right? If they both equal each other, can one side increase, one side decrease? No. So it shouldn't be C. It should be B. The rate constant value would theoretically decrease. Why does it decrease? Because you're making more reactants theoretically, right? Yes. Which is exactly what the next one is saying. We'll find that out. So, those of you who took my Chem-115 class, make me proud. What does delta H mean? Huh? Change in heat. Now your teacher's probably said something like change in enthalpy. Don't do that to yourself, because guess what's going to happen in a couple weeks? In about 6 weeks, we're going to learn a new concept called change in entropy. Entropy, enthalpy. If you have Deo, his accent's very hard to tell the difference between entropy and enthalpy if he talks very quickly. Langley, a bit much. He talks a bit slower, but it's still hard. If you don't hear the th for the entropy, it's kind of hard, right? So I don't call it entropy or enthalpy. I call it something else. Delta H is the heat. It's change in heat energy. If I say heat energy, what's that mean? Change in what? Change in temperature. Good. So it's change in temperature. Now, negative value in temperature. Exothermic, endothermic. Exothermic. Good. What does that mean? What does exothermic mean? Heat is being released. If heat is being released, where does it go? Products or reactant side? Product side. It's going to be released, right? So it's going to be part of the product side. So if you're given delta H, just write it down that it's part of that side. If it's negative, it's part of the product side. If it's positive, part of the reactant side. And we treat it as a variable now. Make sense? So if I increase the temperature, right? An increase in temperature, is that going to, it's going to increase the product side, right? How does the Chatelier's principle say the reaction is going to react? Is it go in the forward direction or reverse direction? Go right or left? I just increased this side by a lot, right? It's a balance, right? Think of a balance beam. If this side went up, I have to counteract it, right? So that side just went up. I'm going to shift towards the left. I want a different color. I wanted a different color. I want it. Give me, no. Oh God, what is that? What's going on? It's going to shift towards the left because I increased the heat. Good. So if I shift towards the left, what should increase theoretically? The amount of carbon dioxide I have, right? I won't have an increase in O2, right? I won't have a decrease in O2. I won't have an increase in CO. Oh no. I'm gonna have a decrease in something. Same thing like problem above. You have a decrease in the equilibrium constant. Does that make sense? You're saying no? I second that. Does that make sense to everyone? Yes? No? Maybe so? You know. What's K equal? If reactants go up, how much is the K? Doesn't it go down? Theoretically speaking, yes. Okay. Number 12. Hey, Le Chatelier's principle, yet again, predicts that at equilibrium pressure. So at equilibrium, the pressure of that will be maximized by carrying out what? So it wants to maximize something. If I want to maximize something, what does that mean? I want the most out of it, right? So I want to make the most amount of this stuff. That stuff, carbon monoxide, where's that found? Yes, number 11 was B is yes. Okay. Cool. Okay, it's products. So I want to make as much products as possible, correct? Okay, so again, delta H means what? Change in heat. That guy right there is exothermic. It's negative, right? Products or reactant side. Product side is going to be on the product side, right? You have heat there. So if I increase the amount of heat, am I going to shift it towards the right or left? If I add more heat, I'm going to shift it towards the left. Is that what I want or no? No, I want to make more products, not reactants. So it ain't going to be at the high temperature parts. It's going to be at the low temperature ones. Does that make sense? Okay. Up next, the principle between volume. An increase in volume favors the side with the most amount of moles. A decrease in volume favors the side with the least amount. And then products and reactants are the exact opposite, right? So a decrease in pressure, an increase in pressure. So how many moles do I have on my reactant side? How many moles do I have on my product side? So which side has more? The products have more. Okay. So I want to either increase my volume or decrease my pressure. Does that make sense? At low temperature, low pressure. That's how you would maximize that. Does that make sense? You're shifting it towards the product side by a lot. So theoretically, the K value will go up. Yes? So, so when doing chemistry, you got to think about chemistry this way from now on. Chemistry are particles coming together and running into each other to form something, right? So think about a water bottle right here, container, right? If I have product gas particles and reactant gas particles, let's say for example I have more product gas in here. If I compress it, right? The particles have less room to move around. This means they're more likely to run into each other. The products run into each other, they're going to make reactants. That's why Well, no, their products are going to run into each other to make reactants. Remember, equilibrium is both sides, theoretically speaking, right? So I'm going to force it to go to the side with the least amount, right? Because take the side with the most and force them to run into each other, right? That's why a decrease in volume favors the side with the least, because they're forcing the other side to collide with each other, theoretically speaking. Does that kind of make sense? Okay. Sit down now, actually. How's my face look? Make sure you guys aren't looking at my crotch or something. Kind of weird. Hi. I need a haircut. Jesus. Only if it wasn't dangerous to go to a barber shop. Why do we trust people with sharp objects near our faces? A lot of the times it's weird. Society's a weird place. Ooh. You all have taken 181 at least, hopefully. What's a catalyst do? What? What's a catalyst do? What is the activation energy? What does that mean? Speeds up the reaction. If I have this occurring, this is the reaction. It goes both directions. So a catalyst will just maximize it and makes it easier, right? It's going to increase the rate at which the equilibrium is achieved without changing the composition, right? It's going to make it quicker to equilibrium. It's not going to favor one side, ain't going to favor the other side, and I don't know what this means. Solar version only 4. I don't know what that means. It's a typo right there. So don't pick E. Answer's A. Make sense? Oh, that's not the eraser. Okay. Hey, we're making good progress. There's only 50 more depressants to go. Or something like that. There's 50 total, yeah. Le Chatelier's principle again. The following reaction to equilibrium is at a close at a constant controlled temperature. What effect would adding more hydrogen gas? Yes. Yes, 13 was A. Cool. Don't do this to get the answers, guys. Do this to learn. Because if you guys just do this to the answers, I'll get in trouble. Do it to learn. I'm teaching you guys via a teaching model that is similar to the quiz. Hint, hint, wink, wink. Okay. We're increasing this guy right here, right? If that guy's increased, Le Chatelier's principle says what? What side is it going to shift towards? The left or the right? Shift towards the left, which means I should make more what? Reactants. The concentrations of CO and HO2 will all increase. Well, this is good. This is good. That ain't good. That's not true.
Okay, so is it essentially if the right is increasing, it's going to the left?
Yes, essentially speaking, yes.
Okay.
Yes. Right? The reason I crossed A off is because H2 would go down at equilibrium, right? As you approach equilibrium. What should occur is an increase, and a decrease of CO2. So number 14 should be C. Does that make sense? How many questions in a row do we have Le Chatelier's principle? Like 7. It's probably heavily tested on your quiz. It's a good thing. It's a pretty easy concept. We'll just understand what's going on with it. Yes? Why it wouldn't decrease? We're approaching equilibrium. It's approaching more balanced, right? If I add more of this side's got to increase to meet up with the match. Right? That's why these would increase and this would decrease. Because you're trying to keep equal to each other. Hey, I mentioned these before on purpose. KF, KR, what's KF? Constant the forward. KR, reverse. So the arrow that points the forward direction, that's going to be the forward. The arrow that points in the opposite direction is going to be the reverse. What this just basically means, the Kc value will be Kf over Kr. Yep. Unless you flip it somehow, right? Unless you like literally put B over here and A over here for some reason, but we don't ask you to do that type of questions for this one. Yep. I hear all the typing of calculators furiously. What'd you guys get? What? 8? Oh, like 8's on answer. E is the correct answer, yes. E is the correct answer, 15. Cool. I would come and check you guys' work, but I don't want to be here all day. Huh? Okay. We're fine. We're almost done. We're halfway done. Or close to. You have a Kc value, right? For the reaction, suppose a particular temperature has a Kc value. Suppose the system's at the temperature is prepared, and you're given weird concentrations. If you're given a Kc value and asked to plug concentrations in, guess what you're doing? You're getting a Q value. Remember, Q is just the same thing as a K value, because it looks like the same letters apparently that the chemists who designed that concept, right? So we're going to figure out what Q is, and Q is the same thing. It's products over reactants. In this case, it's going to be PCl5 over PCl3 and chlorine. Actually, concentration with brackets. Okay. Tell me what the Q value is. Figure out Q. What is it? 40. Yeah, you're right. Okay. Sorry, guys. I have all 50 questions in my head. I don't remember which numbers go to which one. Okay. The Kc value is 24. Which one's bigger, Q or K? And what happens when Q is bigger than K? It's going to shift towards the left. You're going to make more reactants to compensate. So, A, are they equal to each other? Well, that's, yeah, no. The reaction will proceed in the direction of forming more PCl5 until equilibrium is reached. No, that's products. The reaction will proceed until you make more reactants. That's true. So the answer is C. Does that make sense? Okay. Cool. Yeah. Exactly. Yeah, that's why I'm saying it. Yeah. If you want to, yes. I don't care. I used to draw teeth to piss Langley off. I used to do that just to make him mad on purpose in my tests. Because that's what my grade school teacher taught me, and it stuck. I call it alligator mouth. I don't like less than or greater than. That stuff confuses me. Alligator mouth is much easier. What's up? Okay. I'll have a recording. Just email me when you want it, and I'll send it to you. Okay. Hey, Le Chatelier's principle, yet again. Woohoo. Wait, 17, right? Oh, I skipped one. 17 it is. Wait, not Le Chatelier's principle. This is just math. Kc value. What's Kc equal to? Products of reactants. Hey, I'm going to beat this into you guys until you guys can do this blindfolded. Because guess what? You're going to do this blindfolded. So now just plug in your products and reactants. So what are your products? What are your products? C squared D. What are reactants? A squared B cubed. It's all good. After cube, just say to the 4th power or to the 3rd power. It's all good. Plug your numbers in. Of course. If you gotta leave, guys, go. I'll have recordings of this stuff. I know labs are going on right now, so that's fun. Okay. C squared something happening? Okay. We'll just plug those values in, and we should get an answer. Yes, Matthew, you are correct. It is D. The Zoomies have 1 point on you guys. I'm keeping track. Okay, 18, Le Chatelier's principle yet again. I keep making this on purpose because guess what? It's important. Okay, what type of form, what are our forms of matter here? They're all what? They're all gases, which means they all matter. Darn. Okay, I got a delta H value. It's negative. Products or reactant side? The product side. It's exothermic. Okay, so what stresses will make more HCl gas? Okay, so we're adding more this. If I add more chlorine, will that force the reaction to make more hydrochloric acid? HCl, yes or no? If this side go up, how does the other side have to counteract to that? Go up as well, right? If I add more of this stuff, right, this side has to go up by the exact same amount, theoretically speaking. So, number 1 is correct. Raising the temperature. What side is temperature on? The product side. If the products go up, what's the reactants have to do? Go up, theoretically speaking, right? For the reactants to go up, the products have to go down. Do we want our products to go down? No. No. Decreasing the volume. Remember, write this out, you have to. A decrease in volume favors the side with the most amount of moles. Yes, it is. I misspoke. Yes, I did. My bad. The arrows go up, up. My bad. Increasing volume, side with the most. A decrease in volume favors the side with the least. I messed up. I do apologize. Thank you for catching my mistake. I always catch my mistake, guys. Don't feel bad at calling me out. I don't get mad. I want you guys to understand the right material. Cool. So which side has more? Products or reactants? Products. So if I decrease the volume, what side does it favor? Products or reactants? Is that what I want? No, I want more products. I don't want to favor the reactants. Increasing pressure, I don't know. What's the exact opposite? So decrease pressure, increase pressure. So an increase of pressure is the same thing as decreasing volume. You just told me that decrease of volume is bad, right? Cool. If I remove all the oxygen from this equation, is it at equilibrium right now? No. It's going to shift as heavily as possible to make that up, right? So 1 in 5. Which one says 1 in 5? D. 1 in 5 is D, so 18 is D. Again, Le Chatelier's principle. Hey, it's like if all the problems Le Chatelier's principle. What's special about this one? This one's different. Can you see this positive? Exothermic or endothermic? It's going to be on the reactant side now. So, how will your system respond to an increase in temperature? What side will get bigger? The product should get bigger in reaction to an increase in temperature. Does that make sense? Cool. So if the products get bigger, what should happen to the concentration of products? Go up or down? It should go up. You should be making more products theoretically. That's a product, right? So it will decrease. That's a no-no. That's a reactant. That will decrease. That's true. I like that. All right. It's not entirely wrong. Okay, right there says a reactant will increase. That's a no-no. Hey, that will increase, and that will increase. Okay. Oh, I misread this stuff. Whoopsie daisy. Yeah, products will increase because you're increasing this side, right? To balance it out, the products you have to lose reactants to make products. I misspoke. These are separate ideas right there. Yeah. That will decrease. That is true. Equilibrium constant now will go up or down. What is equilibrium constant? Okay, what is K equal to? If products go up, what was my K value? It go up. My K value should go up, right? So B is wrong because it tells me equilibrium constant will go down. That's a no-no. Okay, the concentration of N2 should increase. B says that reactants will decrease, which is true, right? And the equilibrium constant will decrease. If R go down, what happens to K? It go up. That's why B is wrong, because it's saying one true statement, but followed by a false statement. Okay. Hello, Zoomies. You're being recorded. You can have your cameras off. You can speak if you want to. Your voice will echo in here. It's all good. If you can hear me, good. If you have questions, speak. We're on question 20 on the PQ, which just means practice quiz. Oh, God. More Le Chatelier's principle. Woohoo. I'm getting kind of tired of this stuff. Okay. If I say proceed to the left, what does that mean? I'm making more products or reactants? Making more reactants. Okay. So if I remove water, which way does it shift? The right or the left? It should shift towards the left to make up for the loss. If I remove HI, which way will it shift? Shift to the right. I don't want that. A decrease in pressure is the same thing as saying an increase in volume. And an increase in volume favors the side with the most amounts of stuff. Do they? Uh-oh. Those are solids. We don't care about those. Cross those guys out. So a decrease in pressure, right? Well, an increase in volume is only in favor of one side, right? It's in favor of the product side. I don't want that. That's a no-no. If I add O2, that go up. Is that going to favor the, is that proceed to the left or to the right? Proceed to the right, correct? So you have to balance it out. Proceeds towards the right. Do I want that? No. An increase in volume favors the side with the most. Cancel that out, cancel that out. Where is the most amount of moles of gas? On the reactant side, right? So an increase in volume is a good thing. Ding, 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 ding. It's 1 in 5. Again, it's D. Making sense, people? How many questions we got on the Chatier's principle? they're trying to beat in your head, guys, because it is important.
So if it wants to proceed to the left, you just remove something from the product.
Yep.
The reactant side. Okay.
Consider the following reaction at equilibrium. Which of the following situations would cause a maximum increase in number of moles of this guy? I'm not going to say it. Where's that guy located? Product side. So I want to shift everything towards the right. Okay. Check your matter. They're all gases, which means they all count. Okay. And then the change of heat, right? Exothermic or endothermic? It's endo, which goes on what side? Goes on the reactant side. So if I increase temperature, is that good or bad? If I increase the energy and temperature, it's going to increase reactant. It's going to force it toward the right side, right? To counteract it. So I wanted high temperature. Good. Remember, an increase in volume means you favor the side with the most. A decrease in volume favors the sides with the least. Keep repeating myself because that's how you guys should be doing these problems. Yeah, cool. So, what side has more moles of gas? Reactant or product? That's 7. That's 2. So let's not force it towards that side. So we want to decrease the volume. A decrease in volume means low volume. So B. Does that make sense? Ta-da. Oh, yeah, we actually do some math for once. Woohoo! Cool. Oh, no. Oh, gosh. Which one's this one? Oh, okay. So, those of you who helped in the homework, this is the first time you should see a problem like this. The homework had like 7 of these problems in it. KP and KC are related to each other in a weird way, right? The way they're related to each other is KP is equal to KC times RT delta N. That is the formula. If you need help to figure out why it's like that, I can tell you it's based off Pivner. But just know that this R value is the gas constant, 0.0821. What is T? Temperature. Temperature in what unit? Kelvin. Not Celsius. So, Kp value, looking for Kp value given Kc. You're told that Kc, right here, plug Kc in, plug RT in, change this by adding 273. That's for time. The only weird thing about this guy is this little change in N. What is N? That's great. What does that mean, though? The number of moles of products minus the number of moles of reactants. 3 minus 2. Because you have 3 moles of products minus the 2 moles of reactants, right? What's that equal? Should equal 1. Plug a 1 value in there. Does that make sense? You guys are saying things correctly, but the way you're saying it, you're going to confuse yourself later on.
Is it always reactants minus products?
It's products minus reactants. Always, always, always products minus reactants. Always, always, always products minus reactants. So it's change in, right? And change in means what you have minus what you started off with. That's how you figure out a change, right? Yeah. Oh, it's chapter 16. I like 16 so much better. Ugh. For 22? Yeah. 22 is E. Okay. Zoomies, any more questions for me? Cool. Hopefully you guys aren't too lost. You guys are if you guys are too lost, speak up now. Rewatch this video when I give it to you guys, or vice versa. Okay. At 700K, the equation is given. The Kc value is that. The following concentrations are present. Is the mixture at equilibrium? You're given a Kc value, right? You are then given every single concentration available to you. What's that mean you're solving for? Solving for a Q value. Q is just the same thing as K, right? Products over reactants. So what are your products? SO3 squared, O2 squared, and SO2 squared. Plug your values in, and then tell me what Q is equal to. As I get a drink of water, because my throat is parched. Caffeinated water is the best. Yeah. Nope, put 10 in. Put 10 in. If he made an oopsie, it's his fault. Because everyone else is going to put 10 in. So give this one wrong, go blame Langley. Go talk to your instructor. Yeah. What'd you get for Q? 100,000? Ooh, no, it's 100,000. Even if you didn't get 100,000, it's fine. Q is way smaller than KC, right? This is a gigantic number, right? Times 10 to the 6, it's a lot of zeros. So, KC, Q. Alligator eats the biggest mouth, right? You need to, you can draw some teeth. You can draw an eyeball if you need to. But it's going to eat it's going to eat KC, right? Which means Q isn't done growing. It needs to grow more, right? Which means it's going to shift it towards the right. It goes from the left to the right. And they are not at equilibrium. Make sense? If it doesn't make sense, ask questions. I don't get mad at guys asking questions. Why don't you guys ask me questions now? Yeah. 24. Which one of the changes below would cause the equilibrium to shift to the left? Okay, look at our values. They're all gases, means they all count. That guy right there, that's a positive number, means he's endothermic. Yes. Up to right. That guy's positive, which means he's endothermic, which means you add heat is being added to the reactant side. Good. So I want to proceed to the left. What does the left mean? Left means what? Reactants. Want to make more of this stuff. That's at equilibrium theoretically, yes. They mess up the arrows. I agree. Okay, a decrease in temperature. What side would that shift it towards? This side go down. We're gonna shift it towards the left to counteract that, right? So A looks kind of good. So let's put a check mark right there. And guess what? That's the answer. So A is the answer. It's the first one there. That makes sense. Okay. Oh gosh, last one. Okay, which one is true? If Q is bigger than K, the reaction is not equilibrium. That sounds good. And we'll reach equilibrium by shifting to make more products. Is that true or false? Is the first one true or false?
If it shifted to make more products, it could make the same amount of products on the other side. So it could...
Oh, sorry, you're going from products to reactants, my bad. Shifting over from products to reactants, so you're making more reactants. That one's true. If the K value is a big number, products are favored. Is that true or false? What's K equal? Products over reactants. If K is big, what is P? P has to be big or R has to be small, right? If your K value is really big, you're favoring your products. So 2 is true. If your K value is small, you're favoring your reactants, not your products. So 3 is wrong. If K and Q are equal to each other, they're equilibrium. So 1, 2, and 4 are correct. Is there an answer with 1, 2, and 4? C is the right answer. Does that make sense?
Wait, how do we tell if the K value is big or small?
Is it bigger than 1 or is less than 1? If it's greater than 1, it's a big number. If it's less than 1, it's a small number.
Okay.
You're headed out? Okay, that's fine. Okay, now we're going to touch on some territory. Some of you guys have covered this so far, some of you haven't. We're going to talk about acid and bases.
Really quick, where are you guys meeting at?
What?
Where are you guys actually meeting at?
This is a building 6, room 104/105.
Oh, okay.
So if you want to come and make it, come and make it.
Is that where you guys are going to always meet when you do this, or try to?
No, we were usually meet in the North Lecture Hall, but classes were here today for some reason. But I'll let you guys know. It's usually like up in the air where we're going to meet, because sometimes this room is used by clubs. Okay, let's talk about acid and bases real quick. Unfortunately, we're not talking about drugs right now, so no, don't think of like Molly and stuff. So pH indicates what? What does pH indicate? pH indicates the level of acidity, right? What it really indicates is the number of hydrogen ions you have. The more hydrogen ions you have, the more acidic you are. Good. There's an issue though. pH is a negative logarithmic equation. Now, all that means is it's the exact opposite of what you guys think. The lower your pH, the stronger your acid, the more hydrogens you have. So, stomach acid, hydrochloric acid, has a pH around 2. That's pretty acidic. Bleach, NaOH, has a pH around 14. That's pretty basic. Does that make sense? Okay. But we care about the number of hydrogen ions. Now, if we talk about POH, that's talking about how basic something is. Same thing. The lower the number of POH, the more basic something is. The higher the number of POH you have, the more acidic you are. Does that make sense? Okay, with pH, what are you looking at right now? Acidity. POH, what are you looking at? Basicity or alkaline, right? Good. The lower the pH value, more acidic. The lower the POH value, the more basic. The higher the pH value, the more basic. The higher the POH value, the more acidic. They are opposites of each other, yes. No, the p-value just means negative log. So, we're going to talk about that right now. Someone brought that up. No, you're good. Never apologize. So, if I add water plus water, stuff's going to happen. So, an acid is something that donates a hydrogen. So, pop off a hydrogen from this guy and add it to this guy, right? You'll get H3 plus. And you also get OH negative, right? OH means base. An extra hydrogen means an acid. Does that make sense? So the guy who donated his hydrogen is an acid. The guy who accepts the hydrogen is basic. Does that make sense? What do you mean the same? Yeah. It's going to go backwards and forwards. The reason this is, so the most common thing you guys come in contact with in your entire life is what? Water, right? What is the pH of water? 7, right? It's neither basic nor acidic, but it can be both depending on the circumstance, right? It's called amiprotic. It can be a base or an acid depending on what's reacting with it. That's why water is good. That's why we're based off of water, right? This is just hypothetically speaking, okay? Okay. On this side, we're just going to look at this side right now. Which one's the acid? Which one's the base? That's your acid, right? This is your base. However, since they are on the product side, we can't just call them the acid and base. We call them the conjugate acid and the conjugate base. The acid is the conjugate base. The base is the conjugate acid. You're gonna make a confused look. What happened to this guy right here? What happened to him? Okay, and became what? Good, right? He has to be the base to get the hydrogen back to become what he just became. Does that make sense? Yes. Get the hydrogen back, yeah. Because remember, this is an equilibrium. Does that make sense? I'm trying to teach you guys concepts like this. It's fine. Yeah, it's one's a bit harder because I haven't had this topic yet. So, pH is equal to the negative log of your H concentration. Does that make sense? So number 1, or number 26, number 1 of chapter 16. So your pH is equal to that. So calculate pH. So we know pH is the negative log concentration of this. So guess what we talk about now? another concept called strong acids, strong bases. There are 7 strong acids you need to memorize. And guess what? Do you know your 7 strong acids? Guess what you don't need to memorize? Any weak acids. Your strong acids are HClO4, HCl, HBr, HI, and we have H2SO4 and Hno3. These are our 6 strong acids. There's 6 there, not 7. There's 6 strong acids. These ones you have to memorize. Hno3. H2SO4. This one right here. So, the reason these are strong acids are very important. Strong acids dissociate 100%. What that means is they break up apart, right? So, if I had sulfuric acid, would you guys want to drink that? You would want to drink sulfuric acid? Don't tell me that. If I had citric acid, would you want to drink citric acid? Would you guys want to drink citric acid? Yeah, it's lemon juice, orange juice, fruit juice. That's a weak acid. You drink that stuff, right? You guys drink soda. That's a weak acid, correct? You guys deal with acid and bases all the time. You don't deal with strong acids and strong bases because they kill you because they dissociate 100%. Okay, which means they break up into the stuff. Doesn't memorize any weak acids. If they're not one of the, if there's not one of those 6 strong acids, guess what? It's a weak acid. That's it. So HNO3, it's one of the strong acids, correct? Which means it dissociates 100%, which means there is no reverse arrow. It only goes in one direction because it is strong. You'll make this, and you will make this. Does that make sense? So the concentration of this guy is the concentration of your hydrogen. Does that make sense? Yes. It would be, yes. But since you're dealing with a strong acid, there is no conjugate, theoretically speaking, because you almost never can force it in the other direction. Strong acids only go in one direction. Yes, it means equilibrium, yes, because you're dealing with weak acids and weak bases. So, to figure this out, just take the negative log of that number. So what's the negative log of 0.208? That's your pH. Is that a big number or a small number? That's a small number. That's a strong acid. That make sense? For pH. Well, it's very important. You gotta see which one you're indicating with. Because guess what, right here? pH and POH. So pH is equal to 14 minus POH, and POH is equal to 14 minus pH. The reason that is because POH goes up, the pH scale only goes up to 14, theoretically speaking. It technically can go higher or lower, but that's when stuff becomes so reactive it kind of just explodes by itself, which we don't touch in Gen Chem. We should be touching that stuff. So 14 minus, oh, sorry, yeah. So we're doing with this right here. Not 14 yet. So KOH. What am I dealing with right now? A weak acid or a strong base, right? Because the strong bases are lithium hydroxide, potassium hydroxide, sodium hydroxide, calcium hydroxide, and then you have barium hydroxide, the ones that want you guys to memorize for right now. Yes, KOH. Which we have right now. Does it make sense? It won't make a lot of sense because we haven't had class on this yet, but once you guys have class on it, you'll just understand it way better. Okay. So, erase this real quick. This is a strong base. Dissociates 100%, right? Which means our POH is just going to equal the negative log of our concentration of our OH, which is just this guy's concentration. Plug that in. Tell me what you get for the POH. .6. So the POH is 1.6. pH is equal to 14 minus 1.6, because that's the POH, right? So what's 14 minus 1.6? What is it? 12.4. So which one of these guys has the correct pH and correct POH? What? A is wrong. You have it inversed. It is B. Why? So, it has an OH value, right? That tells you it's a base. It's also one of your strong bases, right? That's how I know. You have to memorize your strong acid and strong bases. Yeah. If it isn't, ice table time. Yeah. Guess what Chapter 16 is all about? Ice tables.
Hey, I'm sorry, why was it 14? 14 minus?
14.
Yeah.
There are two reasons why. The reason if you have Langley, it's going to say that is the KW, or the way water works, right? Water has a P. It's kind of weird to explain this way. I don't like the KW way of explaining it. That's just how high the pH scale goes, right? It goes up to 14 in undergraduate, correct? So if your POH was 1.6, right? That's a very, very strong base. You got to figure out how it works in the opposite scale. So that would be for pH would equal 14, which is the max, minus that to get 12.4. Does that kind of make sense?
Yeah, so it's kind of like the kind of constant for
It is
the.
a constant, yes. 14 is the constant for both of those. You'll see it pop up a lot.
Okay, thank you.
There's something called the dissociation of water. That's something Langley will tell you. If you don't have Langley, don't worry about dissociation of water. It's not that important right now. Hey, HX is a weak acid. Oh no, weak acids. So with weak acids, I don't care what they look like. We're going to hypothetically always call them HA, because I don't care. They're not strong enough for me to care about. It's equilibrium. It breaks apart into a hydrogen and into whatever A is. In this case, it's X. Does that make sense? This right here is called the generic weak acid formula. It is a hydrogen attached to whatever you want it to be. We used A for this example. If you want me to, you can put X in there. You can put Y. Whatever you want to put something there. It's the weak acid formula, generic weak acid formula, right? It's a weak acid, still an acid, so it's still going to donate a hydrogen. It's just going to go back and forth. There's going to be equilibrium. Does that make sense? What does K equal? Products over reactants. If I put an A here, what's that the equilibrium constant for? If I put a K, if I put a B there, bases. So we're still dealing with products over reactants, right? Now we're going to focus on an ice table. So, beginning of all ice tables, you should have no products. How much of this do you have? You have 0.59 of that. Does that kind of make sense? Cool. There's a change, right? That change is X. So the N value will be 0.59 minus X. Now, raise your hand if you like the quadratic formula. Want to know a trick to not use a quadratic formula? This is a weak acid, right? If it's a weak acid, will it donate all of its hydrogen? Yes or no? Will it donate all its hydrogen? No. Thus, you can kind of ignore the X value right there, because the X value is going to be very, very small. It's insignificant, theoretically speaking. Correct? Because it's a weak acid. So you can just get rid of or scribble out that X value. Plug this into Ka, which is products of reactants. So what are my two products? X times X. What's X times X? Then I plug in 0.59 to my Ka, which is given to me, which is 7.3 times 10 to the negative 6. How do I solve for X? Yeah, multiply 0.59. Find there, get rid of it. Then what? Square root, cancel that out. So you take the square root after multiplying those guys together, you should get your X value, which is your concentration of hydrogen. You are not done yet, because what is it asking for? The pH. The pH is equal to the negative log of that value. So whatever you get for X, you plug it in for there, and the negative log for that value, and you should get the right answer. Does that make sense? Chat, any questions? Or Zoomies, or whatever it has been called. So what do you guys get for X? Oh, still doing it, okay. Yes, you are correct. Yep, it is. Good job. The answer is B. The pH is 2.68. Yes, I can walk through the math. So, what part do you guys get stuck at? Okay. So, I still makes sense, right? These guys right here are my products. They go here, theoretically speaking, right? So X times X is X squared. Okay. Write this up real quick. 0. Yeah, so 0.3 times to the negative 6 value, right? Okay. What is that times 0.59? Yep, 0.59. So you got 4.307 times 10 to the negative 6, you said? Okay. I don't know how you got that, because I got something entirely different. Check your calculator again, because you're off by a lot. 7.3 times 10 to the negative 6 times 0.59. No, it's 5.9. That's why. Okay. We then are going to take the square root of that to solve for X. What's the square root of that guy? might have to put parentheses into your thing so you don't mess up. You just look defeated. Okay. If you guys can understand question 28, guess what? That's like 95% of the next couple problems. 0.002. Good. So 0.002. Speaking theoretically, right? The 0.7 is just very, very small number. Okay? That's your X value, right? That's your concentration of hydrogen. Yep, but then you'll take a negative log of that. Your pH. Don't give me that angry look. That's not my fault. Yeah. Okay, you're just looking down at me. It's really hard to read you guys' facial expressions when you like have mask on. 2.698. What's that closest to? Okay. You probably won't get the right answers on a lot of the PQs because we changed the numbers to try to trick Chegg. It won't work. But yeah, also because some calculators are just a bit different. Also how you round. Okay. Come on, erase. There we go. Okay, if you guys can do 28, you're pretty much set for chapter 16. So, was this one of the 6 strong acids I gave you? Was it? HClO4. So, is this a strong acid or a weak acid? Hey, guess what we have to do then? HA is broken down to hydrogen plus A, ice table. You have none of these guys. You're going to add an X value, subtract an X value. You start off with 2.5 times 10 to the negative 4th of that guy. But remember, since theoretically X is such a small value, you can say it's like negligible, so you don't have to do the quadratic formula. Does that make sense? If you guys really want to do quadratic formula, go ahead and do it. So I don't want to do it. So we're just going to say that the N value doesn't change it at all. Ka is equal to the products of reactants, which with 2 products times each other is x squared over 2.5 times 10 to the negative fourth power. What? Yes, x is negligible because it's a weak acid, right? If it was a strong acid, you could just plug it straight into the negative log equals pH thing. Our Ka value is 3.5 times 10 to the negative 8th, right? Same thing, solve for x. And I'm not kidding, guys. We're into the exact same thing multiple times in a row. Oh, I messed up. I read the problem wrong. That's my bad. That's my bad. I messed up. Blame me. I messed up. 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 That's my bad, guys. Sorry about that. It's lack of sleep. So, I misread this guy right here. That's the pH of what? That guy. Now, pH is equal to the negative log of that. Right? I do apologize for that. I messed up. So ignore the last 5 seconds of me speaking. Okay. So pH equals negative log of H plus. Right? Well, I have my pH. How would you find the concentration of H? No, let's say if I'm pOH. 10 to the negative power, right? Because the opposite of log is base 10, right? So to find your H concentration, right, it's base 10 to the negative pH. As that. Why? Why do you do that? Because this is right here what the question's asking. What concentration? So it's asking the concentration of this guy. That has the same pH as this guy. So what you got to do is figure out how much this has. Now, you can do this and this problem if you guys didn't realize something. Is that one of the strong acids? This is why you guys do this. You guys remember the 6 strong acids. Is that one of them, Hno3? Yeah. So what's that mean? Dissociates 100%, which means the concentration of that is the concentration of our hydrogens, right? So this is the amount of hydrogens present. Does that kind of make sense? Yes or no? Yeah, I'm getting like this. I don't know what this side to side like this means. Does not make sense. Okay. When this guy breaks down, it breaks down 100%, right? So when HNO3 breaks down to hydrogen plus NO3, there is no reverse reaction, only a forward reaction, right? So how much you start off here, you're going to have that much right there. Does that make sense? So the amount of hydrogens is that right there. Does that make sense so far? Good. The whole ice table is what we needed to, but we need to figure out how much hydrogen we started off with. So we've got to go back to the HA, not plus, H plus A. So, how much of this do we have? $2.5. So normally we would have nothing in our initial, or we should have nothing in our initial theoretically, right? Speaking. But since we have this, we know what to plug in for X, because X will equal this, correct? So our normal weak acid Ka value is always going to be X squared over HA. We're solving for HA in this case. 3.5 times 10 to the negative 8th. We know what our X value is because we're told it's the same as the same pH as this guy. So you can get rid of your H value and just plug in 2.5 times 10 to the negative 4th. Square that. This is what we're solving for now. That's my bad. I misread the problem. That's why you guys got confused. I do apologize for that. So that's what you're solving for, is that guy down there. How would you solve for that guy? Yep, so that you would multiply this side by that side, right? Then divide. So it's going to be this. So how much HA do I theoretically have? After plugging this in. Okay, which one's that? Yeah, I got quiet. Yes, I did. So I skipped the ice table because guess what? Every time I mention weak acid with an ice table, it's always going to be Ka X squared over HA. It's always going to be that. always going to be what that is, right? Because you're always going to have an H value, which you want, and how much ever leftover conjugate base you have, right? Theoretically speaking. So it's always Ka is always going to equal x squared over HA for weak acids. Okay. Monoprotic weak acids. Monoprotic weak acids. We'll don't worry about diprotics after this quiz and exam. Okay. 30. What is the Ka of the weak acid? Tells you the weak acid. If blank of the acid has a pH of 2.2. So calculate ionization. So what are we dealing with right now? So does it have a high ionization energy or low? If I tell you strong acids ionizate 100%, it's the weak acid, it's low, right? So you can assume the X is negligible, right? For weak acids, always assume the X is negligible. So you're given pH, you're solving for Ka. What is Ka equal to? On pH, it's a concentrate. Theoretically, it's a concentration of H over concentration of A, right? Which is use your X values divided by HA. Does that make sense? Okay. So we're solving for this guy now. So we got to figure everything else out. I have my concentration of my weak acid. It's right there. How do I find the concentration of my hydrogen? There's multiple ways of doing it. What's the easiest way? I already gave you the pH of it. How do I go from pH to hydrogen? No, negative log. So remember, pH is equal to the negative log of H plus. So why did I figure the concentration of my H plus? Base 10 to the negative 2.22. It's base 10 to the pH value, right? So it's base 10 to the negative pH. In this case, that is your pH value. Does that make sense? Okay. Zoomies, how you doing? Is there anyone left?
Google, right?
Okay. One voice is there at least. Okay. Yes. And what do you get for H plus? Zero 0.06. That's the number of hydrogen, right? That gets plugged in. That's your X value. So that's plugged in twice, right? Because remember, HA is broken down into hydrogen 0.006. Yep, it is. My bad. There we go. So we're going to take 0.006. We're going to square that value and divide by 0.106. What's your K value? Ka value. Which one's that one? Or closest to? Well, because whatever this equals, this has to equal the exact same thing, right? Because they're being broken out at the exact same rate. The X squared, yes. You guys have questions, you guys can ask. Don't be afraid of me, I'm not mean. Man, some of your professors made you guys very fast questions. What? then what you're going to do is you're never going to round. Never round. Never round. You just, whatever you get, put that entire equation into the entire thing. Never round to the very end. I round every which way. That's a bad habit I have. With you guys, just never round whatsoever. And to the very, very end, then you'll shoot the right answer. Yeah. Okay. Anyone have any questions in this one? What? Ka? If your Ka is negative, what's that mean? Can you have a negative Ka? No, you never have a negative Ka. Your Ka should never be negative. That means you're not producing anything, theoretically. You're not making anything. Somehow it's weirdly being destroyed. Okay. 31, determine present ionization. So we actually favor percent ionization. What is percent? What does percent mean? Like if you guys got like an 80% on a test, what's that mean? Partial, right? Something out of a whole, right? So this right here is your weak acid, right? Theoretically, it's a weak acid, so it's going to be equilibrium, right? So we should have, we can maximally only make this much, right? So that's our whole that goes in the bottom. What we get for H, we'll put up top, and that will be our theoretical, right? Cool. So Ka, right, is always going to be equal to the concentration of H, the concentration of HA, or just A, sorry, over HA. Right? Are you given Ka value in this equation? So plug that in. 3.5 times 10 to the negative 8th. Are you given an HA value? 0.14. Are you given the amount of hydrogen or the amount of A? Yes or no? Mention anywhere in here? Give you the pH, concentration of anything? No. So those are going to be our X values. So X times X is what? X squared. Solve for X. Does that make sense? Okay. Once you get X, just plug it in right here. Yeah, phone's going off. What's going on? What'd you get for X? Yeah. So 7 times 10 to the negative 5. Okay. So after you plug it into this, you got C. It's all good. What'd you guys get? This should be a little confusing because you haven't taught this stuff yet. So don't feel bad if it doesn't make any sense. Come back and look at this stuff. I'm recording this right now. Come back and look at it once you guys have lecture. It'll make one more sense. 4? 31. Okay. What's that closest to? D. I don't know how you got 10 to the negative 4th. Huh? Oh, okay. I got negative. Okay, let's see there quick. 7 times 10 to the negative 5th. That guy divided by 0.14. Okay. Apparently, but that's the answer is D. So that's weird. Yeah. The answer should be D. I don't know why I got 2.4. I gotta check my math on that later, but I know the answer is D. Okay. Because this right here is your maximum, right? It's the amount of HA you have. So that's the total amount you can make, right? This is the amount of hydrogen you did produce, right? So your percentage on your test is this. Is that a good percentage to get? 5 times 10 to the negative second. Would you want that score on the test? That's less than a 1. It's less than 0%. So you lost points, theoretically speaking. Not good, right? So anytime you see the word percent, think out of 100. You guys can calculate your test scores immediately, but anytime you ask to calculate the percentage of something, you freak out. It's hilarious. Okay, Zoomies, any questions?
I don't have any.
How many Zoomies do I have? Got Liam. I got Erica. Okay. Erase that. Cool. 32. So 5.7 ionization. Okay. You want to do this the easy way or the hard way? Both. Gosh, okay, fine. I mean, if you want to do it both ways, that's fine. Okay, there's 2 ways of doing this. Percent ionization. So I got 5.7% ionization, which is equal to the concentration of my H's over the concentration of my HA. Right? What am I solving for? So do I have H concentration? So I'll put an X value in for that guy, right? Cool. Am I given my amount of weak acid? Right? I'll plug that in. 0.14 over X. That is equal to a point ionization score of 5.7. Percentage. How do I get rid of percentage? What do I do? No. Divide by 100. How do you get rid of percentages? Divide by 100, right? So take your 5.7, divide by 100, what do you get? 0.057 is equal to X 0.14. 0.00798. Okay, round that up. E? A. That's the easy way. Want to know the hard way? No? Okay, I won't teach you the hard way then. Ka is equal to x squared over HA. X squared is the same thing as H, right? Solving for this guy. You already have HA, 0.14. You're given Ka, 5.4 times 10 to the negative 4th. Solve for X. You've done that before, right? The reason this way is harder because you have to square root something. Does that make sense? Both work. Both the exact same answers. I checked. Both work. Monoprotic weak acid, when dissolved in water, has a 36% dissociation and has a pH of that. What is the Ka value? Oh no. This one we have to do both steps now. So remember, percent ionization. 0.36% is equal to concentration of H over HA. And remember that Ka is equal to x squared over HA, and all x squared is just the concentration of your hydrogens, right? So guess what we have to do? We're gonna figure out one of these things. We have too many variables because we're trying to find this guy, right? Well, that's a variable. I got a variable here. Well, can you? Is it a strong acid? It's a weak acid, right? Here's what you do. Remember, pH is equal to negative log of H squared. It's H squared, so H, concentration of H, right? How do I find the concentration of my H's? What do I do instead? Base 10 negative log of pH. Took us about 30 minutes to do 3 problems. Yeah. You guys can leave at any time. I'm going to stay go over all the problems. So this is being recorded, by the way. So if you guys want to leave, you can go. I don't know. I know you guys have lives.
Where are you gonna post it?
What? Matthew, you have a life?
Where are you gonna post it at?
In my announcements for my classes, if you're not one of my students, email me. I'll send it to you.
Okay, I am one of your students, so that's good. All right, thank you.
I know.
What's your email?
Shane.dunn@mygcu.edu.
Okay, thanks.
Yep. What? Is it B? I don't know. Just plug it in. Yeah, B? Nope. So, what'd you get for HA then? Yeah. Yeah, ours are for H. 7.9 for H? Okay. You're not done yet then. 7.9, right? So you divide by 100, solve for HA, plug HA into here. We're looking for Ka. Calculate Ka. You got to solve for HA down here and plug that into the bottom equation down here. Last equation was nice because they gave us Ka values. This time I'm going to solve for it. How do you get HA? Uh, 7.9 times 10 to the negative 4th, right? That number divided by 0.0036, correct? Gives you what? 0.2194. So you plug that number in for here, 0.2194. Yeah. So 7.94 times 10 to the negative 4th squared divided by 0.2194 should give you a Ka value. What is your Ka value? We're solving for right now. It's C. Good job, Matthew. It is C. Okay, you guys got it? Yes, because your X value is always going to be equal to your concentration of your H's. for Ka. If we're dealing with a Kb, what would your X value be theoretically then? Concentration of what for bases? How'd you get A? This is the third time you messed up on this equation. I don't know if I trust your calculator right now. Give me a second. Did you square it? See? Okay. 2.84457. Closest one to that is 2.9. Okay. I'm a sassy person, I know. Okay. Everyone good now? Marissa, you okay? You have this wide-eyed look, which is concerning. Yeah, so 7.9 is your amount of hydrogen, correct? Okay. That's the amount of this, yes. So 7.94 times 10 to the negative fourth squared is what?
Wait, I'm sorry, where did it come from?
The 7.94? That came from the pH. You're given pH, right? If you take, so 10 to the negative pH will give you the amount of hydrogen in your pH, theoretically speaking.
Oh, gotcha. Okay.
So you plug that value into here, solve for HA, plug HA in. This right here is the same thing as your X value right there.
Okay. Thank you.
Okay. You guys good? Okay. It's not making sense now. Wait until you guys go over it in lecture and rewatch the video. If it doesn't make sense then, come contact me. Okay. What they're telling you in lecture is going to take you way longer. I'm trying to teach you the fast way of doing this. Okay. What does Ka equal? X squared over HA. You're not wrong, that's correct. What's Kb equal? No, X squared over HB. This is your base, right? If you're dealing with your base, you're not dealing with the amount of hydrogen, you're dealing with the amount of OH instead. Right? It's the same thing. So if you want to say Ka is equal to X squared over HA, Kb is equal to X squared over HB. Okay. So here's your HB, because that's your amount of your weak base, right? Technically B squared. Yeah. Same thing. This is equal to the same thing as this, theoretically speaking. Okay. I just erased HB. Theoretically, would it be HB would be B minus because it wants to accept the hydrogen. But same thing. It's the same thing as that. Okay. So I have that, right? The B minus is 0. I can't read that. Oof. 0.323. How would I find the amount of OH? How would I do that? That would give you the amount of OH, the amount of H concentration. POH is equal to 14 minus 9.58, right? What does that equal? What's 14 minus 9.58? 4 point what? 42. So an OH is equal to base 10 to the negative log of POH. So just take that value, plug it in there. You get the concentration of OH value, right? right? Okay. I trust you again. You can start yelling out answers again. I mean, you guys are tired, already sleepy. It's only 8 o'clock. You get a lot today. It's a Tuesday. What did you do today? It was so much. Ugh, class. Okay. The reason I put it squared here is because this is your new x value, right? Just plug it in right there. So 3.8 times 10 to the negative fifth squared divided by 0.323, and that will give you your KB value. It is correct. Does that make sense what I did? Okay. Lang is going to hate me for teaching that way because I'm not going over concepts. I'm going over how to solve the problems. So you guys care about way more. Yeah, I know. We'll get concepts later. The last like 7, 10 questions. But with this concept with 16, it's more about that. Langley likes concepts, which is stupid. Okay. Well, this is being recorded. I don't like concepts for chemistry. That's more lab. That should be more lab stuff. Okay. Oh, the painkiller morphine is a weak base. When added to water, the Kb value is this. What is the pH value? So, what is Kb? Yep, Kb is x squared over B negative. So, are you getting Kb? Plug it in. 1.6 times 10 to the negative 6 power. I prefer math over concepts. Ugh. Okay.
Thank you, Shane. I'm going to take off. You're awesome.
Okay. I'll see you recording later. Yeah. Have a good night. See you when I see you. Good job. I was waiting for someone to say something. Is it we get for x? Huh? 35 is. Did I not plug it in? Why did I not plug it in? Whoa. 7 times what? I got off by a factor of 10. 1 second. That might be my problem. 1.6 times 10 to the negative 6. Enter. 4.07 times 10 to the negative third. That's that value. That's then take that to that to that to that to that to that. I get 806 times 10 to the negative fifth for x. This is what I got. I got 806 times 10 to the negative fifth for x value. You take the square root of it? Yeah, I'm talking to her. So x is squared, right? To solve for x, I take the square root of it. Maybe a mesh issue. So what's the x represent when we talk about Kb? What's the x represent? Huh? X is equal to either the concentration in your H or your OH. If you're dealing with Ka, it's H. Are we dealing with Ka? No. We are dealing with Kb, right? It's a concentration of OH, right? What are we looking for? Well, if I plug that in, what am I going to get instead? If I plug that into the negative log of OH, what do I get instead? I get POH, correct? Is that pH? Is POH and pH the same thing? No, but I can use those guys to solve for each other, right? Cool. So what's the POH you get? What's the negative log of 8.06 times 10 to the negative fifth? 4.09? Did I write that down? I don't know. 4.09 you say? Let's see. So how do I solve pH then, given POH? You said it, someone said it over there. pH equals 14 minus POH. pH does equal log of H, but we don't need that. We already have POH. Yeah, B. B is correct. The pH is 9.91. Get? Make sense? For some reason, 35 is way harder than 36. You'll see why. Zoomies, how you doing?
Good.
Cool. You following along?
Yeah.
Okay, if your brain's fried, you can hop off. You don't have to stay on. I'm recording this. Okay. Hop off. Don't feel like you have to stay on. I'm recording this for that reason. This is supposed to go, you guys look back at this when you guys are doing this again or going for your quiz or exam. Okay. So, what am I solving for in 36? Cool. The OH concentration of blood is this. Okay. How do I go from OH to pH? Well, is this POH? No, right? POH is found by what? Negative log of OH. A good thing you, it's called, big weird to say. Let's see if I can find it real quick. This might be helpful for some of you guys to jot this down. Why am I zooming in this? Yeah, right there. This right here is, this is all of chapter 16, that little box right there, right? If you have hydrogen, you're trying to go for pH, you take the negative log. If you have pH trying to find hydrogen, you take base 10 to the negative log. If you have pH and you're trying to figure out POH, minus 14, or vice versa. Same thing over there. Now, I will hardly ever touch this top part right here. The reason is because I've helped students my 2 years of teaching before. For some reason, you guys have a hard time plugging that stuff into your calculator. This right here. And students get weird numbers sometimes. It's That's why I stay away from that side, right? There are easier steps, but I stay away from that on purpose, right? That's why I make you guys go from here to here to here. Okay. But this square box thing is fun to look at. You guys want to copy that down if you want to. Just type in that, type into Google. But we go back to our questions now. Go back to the questions. Oh, erase that. Back to questions. Okay. So I have OH. To find the pOH of it, right? To the negative log of the OH concentration. What's my pOH right now? 3.6? 6.6. Okay. Anyone else get that? Okay. 6.6. Good. Is that pH? Okay, how do I find pH? 14 minus pOH. Right? That make sense? So 14 minus the pOH, and plug this in to here. Does that make sense? Your blood should be a pH around 7, right? You're a math program. What do you think? Yeah, it should be around there. Good. If not, Langley would have got in trouble with Bodine. I don't want to see that fight. That'd be a weird fight. These are two different domains fighting. You can always guess in your problems. You can always guess. Are we always going to give you the good answers? No. If you think that we don't like, there's always issues with test questions and answers. That's why it's always going to show, if you guys can have scratch paper, always write your work down, because if something happens, you go, hey, here's my work, can I get partial credit? I don't know if they're doing it this semester, but they do it for other semesters. Okay. So calcium hydroxide. What is calcium hydroxide? What's calcium? What's the formula for calcium? You don't know? Ca. That's calcium. Good. Hydroxide is just OH minus. So what group is calcium in part of? Group 1 or group 2? Group 2. So what's its charge normally? 2 plus. So calcium is 2 plus. Hydroxide is O minus. Are they equal? How do I make it equal? I just put 2 right here, right? So the true form of calcium hydroxide is CaOH2. Is that one of your 7 strong? Is that one of your strong bases? 6 strong bases. It isn't. Strong base. It is. You're good. Which means dissociates 100%. Well, that's going to matter in a couple seconds. So, a saturated aqueous solution of calcium hydroxide has a pH of that. What is the concentration of that guy? Well, is this an acid or a base? Is pH going to help me here? No, pH is not going to help me, right? If pH doesn't help me, what do I have to use instead? What dealing with bases, what should you use? pOH, right? So how do I find pOH? 14 minus 12.25. So what's my pOH going to be? 1.75? Good. What am I looking for though? I'm looking for the amount, concentration of my calcium given this right here. So let's write this formula out, right? CaOH OH2 breaks down to how many calcium ions? Nope, you're not there yet. Right? This guy breaks down to this stuff right here, right? Do you see that? Calcium hydroxide breaks down to calcium plus 2 hydroxides, right? Can POH tell me how much this stuff I have, theoretically speaking? Yes or no? Can I figure out how many hydroxides I would have given that POH value? No. How do I find the POH value? If POH is equal to negative log of OH, what is OH equal to? Base 10 of POH. So base 10 of negative POH, so base 10 of negative 1.75 gives you what? Wow, 4 people left. Okay, that's all good. What's up? I don't know. Did everyone else get that? 0.018? .018. Cool. So that's just how much hydrogen ions you make. Is that how many calcium ions you make? Yes or no? Do you make the same amount? How many more hydroxy ions do you make theoretically? 2 more. So just take your 0.08 and go by 2. What's that equal to? E. 18 divided by 2 is 9, theoretically. Concept question time. Anyone else have a few concept questions there are though? 16 is more heavily math than concept. 15 is where your concept questions are going to come from, hypothetically speaking. I remember more concepts for chapter 15 than 16. 16 is more math. Okay. So, which one is not a conjugate acid-base pair? So what that means, it means conjugate acid, right? So if I hypothetically say, remember if I do the water thing again, H2O plus H2O gives you H3 plus O negative, right? This is my acid. It's going to donate one of its hydrogens. Oh. Yeah, this is one of my acids. This is one of my bases, right? Because it's going to accept it. So, with A, is one accepting one hydrogen, one giving off a hydrogen, theoretically speaking? Yes or no? Is that a conjugate acid-base pair? Well, that's good. We want that. We want which one's not. So A is correct, which means it's the wrong answer. Speaking, B, is one losing a hydrogen, one gaining a hydrogen? Correct. C, is one gaining a hydrogen, one losing a hydrogen? D, is one losing a hydrogen, one gaining a hydrogen? No. So let's talk about something that's going to screw all you guys up come chem lab with acid-base 2. So with acid-base 2, there are things called monoprotic acids and diprotic acids. What does mono mean? What is diprotic? This is the only diprotic strong acid you guys know of. It's diprotic because how many protons does it have? 2. So something that's diprotic has 2 hydrogens. That messes with some of the equations I've taught you so far. That's not until chapter 17 and 18 that we'll talk with those guys. Okay? So right now, everything I taught you will work exactly fair. This right here is saying it goes from diprotic to a noprotic. That's the wrong answer, which means, guess what? That's the right answer. I love not questions, don't you? Guess what happens when you get to grad school? All your questions are not, or except, or that. Ugh. Okay. So, there are 2 ways of looking at basic solutions. You can look at the pH of it, and if the pH is high, that means it's basic. If you look at the pOH of something, though, what's that mean? A low pH means it's basic. Sorry, low pOH means it's basic, right? A low pOH means something is very basic. A high pH means something is what? Basic, right? So, 39, you're giving things in multiple different ways. That's confusing and very annoying. So you got to all convert them all into one equal thing. You want to convert them all to pH or pOH? Which one you guys want to look at first? You want to convert to pH? Okay, so I didn't warn you. Okay. So how do I convert this guy right here to pH? pH is equal to what? Negative log of H squared. So take the negative log of that guy. What'd you guys get? You got 10? Okay. So the pH of that guy is 10. I'll make pH red. I'll make OH green. Christmas colors, I guess. Okay. Well, that's pOH. You guys want to convert it all to pH, right? So what do I have to do? How do I go from how do I find pH given pOH? So what is 6.7 minus 14? Or 14 minus 6, so 6.7. Okay. Oh no, I'm given the concentration of OH. What is it going to help me find? Concentration of OH helps me find what? pOH. Oh, I said I would do green. pOH gives you the negative log of OH. Take the negative log, so you take the negative log of C, should give you the pOH value, right? So what's the negative log of C? $4.2? 4.2. Good. We're converting all, though, into pH, though. That's what the unit was decided to be. Okay. So what's 14 minus 4.2? $9.8. So that'd be 9.8. Good. Now, which one's the highest one? That's the most basic, right? When dealing with pH, the higher you go, the more basic you go. The lower you go, the more acidic you go. Does that make sense? Okay. So I did misspeak. Sometimes you have triprotic acids. Very rarely do you have triprotic acids. Hey, what's the Ka1 value for? What do you guys think Ka1 value is for? What do you think the Ka2 value is for? What do you think the Ka3 value is for? What do you notice by looking at those guys? They go down pretty quickly, right? If you have a diprotic or a triprotic, that last proton is very, very hard to pull off of it. So the more hydrogens you lose, the less acidic you get. Okay. So looking for this guy right here, right? Okay, let's write out the equation. That's the equation, right? Because all it is him losing a hydrogen, right? That's all I wrote out. Okay. So how many hydrogens did I lose? How many hydrogens did I just lose? So which Ka value I'm going to use? 1, 2, or 3? So what's Ka equal to? Yeah, okay. We'll do that first. We can do that. 7.1 times 10 to the negative 3. If you're dealing with Ka, what's it equal to? X squared over HA, basically, right? Concentration of hydrogen of a concentration of hydrogen times the concentration of your thing, right, over HA. So, what's my concentration of my HA? Oh, that's 0.1. 0.1. Solve for the concentration. What is the concentration of X, basically? Solve for X, given that this guy is equal to 0.1. So what does X equal? I am going kind of quickly, but I am also trying to finish on a reasonable time. You guys need more help going over these things more in detail with slower pace? Let me know. I just figured you guys don't want to be here all day. So what's X equal? Sure. Whoa, I got a call. 1 second. No, of course my phone just decides to die right now. 2.7 times 10 to the negative 2. That looks good to me. I love it when my phone breaks. Okay, it doesn't want to cooperate right now. Whatever. No, my phone? I don't know how I can answer a call from my phone on your phone. Well, I can't get the screen to work. So I can't even see who called me. I don't know. Figure out. Probably my grandpa. Okay. Okay. Oh no, what's going on here? We got HOCl. HOCl. Is that an acid or a base? HF. What do you guys think? The base. HF. It's an acid, right? It's a conjugate acid, right? OCl minus. This is my conjugate base. So what's happening here is let's have an acid. It's reacting with the base to make a conjugate acid and a conjugate base, right? They should be at equilibrium. They should. Acids are a bit special though. So the stronger acid always wins, right? So which acid is stronger? HOCl or HF? How do you know? You're correct, but you guessed. No, they both have an extra hydrogen. This guy's a hydrogen. That guy's a hydrogen, right? Oh, they both borrowed it somehow. They're not born with hydrogens. Okay. The way you can tell if I look at the Ka value, the bigger the Ka, the stronger the acid. So which has a higher Ka? What's up? Okay. You're supposed to send, yeah, you send him your procedures, he gives you a data set, and then you plug that in. No. Yeah, you should be able to. I mean, the lab isn't due yet. The data acquisition was due, that's when you turned in. This week, what it's supposed to be due is a separations lab. Yep. That's due in about a month. Okay. If you go to the your student hand guide, like given to you, it's in your, it should be in the path area. There should be some due dates in there. If not, I can send you a screenshot of it. Yep. Yep. Okay. I gotta go back to the review though. Okay. See ya. Yep. So it wasn't Grandpa. It was a student. Cool. So which one has a which K's value, Ka value bigger? HOCl or HF? HF. So this acid is stronger, which means it's going to force the reaction this way. The stronger acid doesn't want to exist. It just doesn't want to exist. That's the best way of thinking about it. It wants to react and not exist. It's going to force the reaction that way. So if I'm thinking about the K value for this equation, right? And I'm given the Ka value, right? So the product Ka value is your HF value. The stronger acid doesn't want to exist. It's going to react. That's why if you put hydrochloric acid in water, it like literally just starts like creating heat because it's breaking itself apart. Okay. And if I put the Ka value for this guy, for HOCl3, you guys told me this guy is way bigger, right? If that guy's way bigger, and my K value is going to be a big number, right? Is it going to be greater than 1? Is 1 a big number? 1's a big number? Okay, no. So it's going to be greater than 1. It's not going to be less than 1, it's going to be equal to 1. So it's going to be A. That's what's trying to get you right here going. Cool. Hey, we only got 10 more problems to go. Well, now we have 8 more problems to go. Woohoo! We're almost done. We'll be done by 10 o'clock, hopefully. So, the K value in this equation is greater than 1. K is products over reactants, right? This is my products. This is my reactants, right? If K is a big number, which one is big? P or R? Products. So equilibrium, the stronger acid is what? So where does the stronger acid lie? On the reactant side or product side? Where the stronger acid doesn't want to exist, right? The stronger acid will break itself down to not exist. All right, so you just told me the product side is being favored, right? So which is the stronger acid, on the reactant side or product side? The reactant side, right? This guy, it doesn't want to exist, so he's blowing himself up to make these guys at a great rates, right? So that's the stronger acid. So this is your acid. Looking at the reactant side, which one of these guys is the base? Just looking at these guys. Which one of these guys would accept a hydrogen? Imagine these guys were at equilibrium. Which one of those would be the base? In the box right here, which one's the base? So what makes an acid an acid? It donates what? So what makes something a base? So which one of those guys receives a hydrogen? To go back to this. HS is what? An acid or a base? It's an acid, because it donates a hydrogen, right? Because is there a hydrogen on this S right here? No. So it got a hydrogen on one side. It has to lose the hydrogen to go back to be what it's being, correct? So it's technically the acid. If that's the acid, that's your base. So the weaker base would be this guy. There you go. That kind of makes sense? Yes or no? Facial expressions are very, very key. All you guys are just giving me these weird, scary looks. All you guys, your brains are fried. Trying to hurry up. Okay. Why can't I click and do that? There we go. So, Hno3, strong acid or weak acid? What's that mean? Okay. So, if I have, so this is the equation right here, right? That's the equilibrium equation for strong acids. There is no backwards or forwards for strong acids. If this guy increases, what's that mean? This guy will increase, correct? Because it's only going to go in one direction. So if you add more HNO3, right, to the equation, what's going to happen to concentration of HO plus? That's the same thing as saying H plus ions. Go up or down? They go up, right? So get rid of the ones that say decrease. Good. If your H plus goes up, what happens to your HO theoretically? It goes down. Is it going to go down? Is there any HO over here? OH, sorry, OH. Yes or no? Is there any OHs over here? No. What? What are you talking about over here? So again, this is all going back to the water thing, right? H2O plus H2O. And you get, right? H3 plus O is the same thing as saying just H concentration. So you guys just told me that this guy would go up, which is the same thing as that right there. So that would go up, right? So if I add something to an acid, so say if I have a bottle of water and I add some acid to it, right? The pH is going to do what? Go up or down? pH is going to go down, right? Down, up. Here's the answer then, based off those two. Increases and decreases. Kind of make sense? That's why that's the answer. You guys make sense? Yes or no? Zoomies, if there's any of you guys left. Why are you guys still here? Okay. 44. So, which one's my acid? So out of these two guys right here, which one's the acid? Look at the entire equation. Which one is giving up a hydrogen? So what's that guy right there? CH3, right? Where'd the hydrogen come from? H2O, right? So H2O gave up a hydrogen, right? Meaning that's my acid. If that's my acid, that's my base. Does that make sense? Okay, going over here. Which one of these guys most likely, which one of these guys have to give a hydrogen up to make the reverse reaction possible? Which one of those guys has to give up hydrogen? So that's my conjugate acid, conjugate base. The only reason I put a conjugate there is just telling you guys it's on the product side, theoretically speaking. That make sense? So, where water is an acid, doop, 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 right? AD, okay, good, good. LOH has to be a conjugate base. The answer is D. Okay. So, this question I can almost guarantee will be on a quiz or an exam at some point. 45. So, an acid does what? Does it accept or donate a proton? And a base does what to the proton? Accepts. Good. And an acid base, the proton travels from the to the what? From goes the acid to the base, right? So if we donates, receives acid base, which is C. I like to ask those fill in those blank questions like that. Oh God, 46 is the hardest one. Because it's so much work. Okay. Anytime you're given pH, OH, right? It's always concentration. What's another way of saying concentration? What? Molarity. Molarity is also equal to what? Look at these guys. Hi, what's up?
Not much.
Okay. So we got to turn all those grams into moles and divide by the liters. Can we skip it? I mean, yeah, you can skip it. I can skip it right now. No? Put this one in the video? Ugh, okay. Oh, fine. You guys are just dead tired. So here's the molar mass it gives you, right? So 4 divided by 40 is equal to 0.1, right? You have 0.1, all right, that's your amount of NaOH, which is the same thing as saying your amount of OH. Because all these guys are strong bases. NaOH is a strong base. To figure out how much you're looking for, I forgot a step because I hate this problem. POH is equal to 14 minus 12 gives you 2. The OH is equal to 10 to the negative POH, or in this case, negative 2. Negative 2 is the same thing as saying 0.01. So we're going to figure out which one of these guys will give us 0.01. So did A give us the 0.01? No, A is dead to us. 12 divided by 40. That gives us 0.3 divided by 1. Is that the same thing as this guy right here? Hasta la vista. Okay. 0.2 divided by 40 gives us what? And then 0.02 divided by 40. Of course, I put the answer, not exactly what it's supposed to be. Ugh. Gives you 0.005. Take that divided by 2, gives you 0.0025. It's the same thing as 0.01. Well, C isn't it either. Kit, Nicole. Why do you guys pop in the very last second? Okay.
Sorry, we just got back from the rock gym.
That's all good. It's all good. I'm not mad. You're being recorded too, so.
I was looking for the recording, but I ended up just getting back in the same session, so I don't know if that's a good or bad thing.
I mean, I recorded everything I went over, so it's all good.
Oh, okay.
I went from 3 people to 7 people in 5 minutes. This is great. Class just got out. 0.2 divided by 0.2 divided by 40 gives you 0.005 divided by 0.5 gives you. Is that the same thing? Am I done? Yes, D is the right answer. That's how you solve D. Okay, so the bigger Ka value means what? The stronger acid. So look at all your Ka values right here. Which one is the biggest one? No. The HCN? 4.9 times 10 to the negative 10th. That is the biggest one?
No, HCl is.
Yep. So, and we're asked to go from decreasing acidity. So which one should be our first one then? The strongest acid, right? So HCl should be our first one. Okay. Well, HCl, the next ones, they have exactly the same. That defeats our purpose. Defeats our purpose. So that just means we should look for the weakest one. So which one is the smallest Ka value? So which one is H2O's last? That's how you solve that one. Make sense? Work smarter, not harder. You guys don't spend too much time in chemistry. You guys spend too much, you have too much other homework to do in other classes. So, which statement is true? So, so a strong acid does what? What does a strong acid do? Dissociates 100%, right? It reacts 100%. It doesn't want to exist. The stronger your acid, if you have a weak acid and you increase acidity somehow, it's going to not exist for longer, right? A is saying the exact opposite. As the concentration of weak acid increases, the percent ionization D increases as well. No. If you have an acid, it doesn't want to exist. As the strength of an acid decreases, the percent ionization increases. That's wrong. Percent of an acid is independent of the identity of the weak acid. So what that just means is that all weak acids are exactly the same. Is that true or false? False? So if I have acetic acid and I have, I don't know, hydroiodonic acid, well, that's also strong acid. So say for example, if I take concentrated orange juice and concentrated lemon juice, which one do you want me to throw in your eyes? Neither, right? Why not? They're both acids. Okay, let's dilute one of them then. Still neither. It's still an acid. And acids, it doesn't matter. An acid is not independent of its identity. And a weak acid is a weak acid, right? They're not all weak acids are created identically, right? Oh, a better example. I was stupid. I'm brain dead. You have this guy, which is acetic acid, and you have water. Which one would have rather throw in your face? Water is a weak acid, is it not? Still considered a weak acid. It's not one of your 7 strong acids, right? So they have the exact same Ka value? Would they have the same Ka value, yes or no? No. So the only one left over is E. I don't like concept questions as a professor and as a student. Okay. So how do you get NABR? Well, NABR, so you get NABR by adding HBr plus NaOH to make NaBr plus water. What's HBr? Strong acid, weak acid. Strong acid. NaOH, strong acid, weak base. What do you guys think? Strong base. It's bleach. Bleach strong, right? That's why you're supposed to drink it. If a strong acid and a strong base react with each other, you form a neutral solution, right? So if you spill hydrochloric acid in you guys' tables, if you pour a basic solution on it, you neutralize it, right? Acid-base neutralization. A strong acid and strong base can neutralize each other. Does that make sense? That is not basic, that is neutral. So that's not the correct answer. So A is out. CaOH2 plus HNO3. Both of those are a strong acid and strong base. Again, that is a neutral solution. You have hydrochloric acid plus, I believe it would be ammonia, right? Ammonia is also an acid because it's positively charged. All positive charged things are usually an acid, right? So a strong acid, let's say I have a bucket of strong acid, right? I add weak acid to it. Is that going to make it more acidic or more basic? If I add acid to an acid, more acidic. So that's wrong. Here I have CH3COOH plus NaOH, right? That is a weak acid plus a strong base. Hey, is that a neutral solution? Can a weak acid neutralize a strong base? Does it neutralize 100%? No, which would be more left over? More base would be left over, right? So that's why that one's the correct answer, because it leaves a basic solution left over. 49 is also, that's 49 is an annoying one. Yeah. Ah, last one. Okay. KW is equal to KA times KB. Now, W, and I want to guess what W stands for. Water. So the concentration of water, Kw is actually a constant. That's 10 or 1 to the negative 14th power, right? All the 14s come from this number. It's kind of, that's the best way of explaining it, all right? If you are given a Ka value and asked to find a Kb value, if you know that Kw is equal to Ka times Kb, for water theoretically, you can just plug this in. Yes. So I'm solving for Kb. So Kb is equal to Kw divided by Ka, which is the same thing as saying 1 times 10 to the negative 14th divided by 6.2 times 10 to the negative 10th. What's that equal?
I got C.
C is correct. Congrats, we finished before 10 o'clock. That was only, what, almost 4 hours of studying? Okay. But that's what the next quiz will be on. Chapter 15 will most likely be on, based on the amount of questions we did, on Le Chatelier's principle. Sometimes finding out Kc or Kp values, given the equation. Chapter 16 will mainly be finding pH, pOH, H concentration, or OH concentration given something. If you're given Ka, Ka is equal to x squared over the weak acid, right? Kb is x squared over the weak base. Does that make sense? Yeah. That's it. So you guys are free to go. If you have questions, ask. But I'm gonna stop sharing. And I'm gonna
Thank you.